So what we're talking about today is a library of parent functions, really just parent functions in particular. And for the most part, our parent functions are stuff we've talked about. The first one, linear and squaring function. Linear function, f of x equals ax plus b. Or we might be a little more familiar with mx plus b, or y equals mx plus b. It's just the equation of a line, slope, straight line, where the slope is a and the y-intercept is 0, comma b. The graph of linear functions has these characteristics. We know what equation of a line is. Let's write a linear function with this here. Well, if we wanted to write this, we're saying that we have a line with a point 1, 3 and 4, 0. And as we've kind of gone over this already, first thing we can do is find the slope, which we could say 3 minus 0 over 1 minus 4, which would be 3 over negative 3, which is negative 1. From here, we can use the y minus y1 is equal to m times x minus x1. Well, the y1 value, we just need to pick one of these two. I'm going to pick 4, 0. So the y value would be 0. The slope is negative 1, and our x value is 4. Now, y minus 0 is just y. We can distribute the negative 1, and we have our equation here. So we've done this in previous chapters already. It's just finding the equation of a line. And one of the biggest characteristics is that the x is to the first power. We don't have a variable, or not a variable, but a power, an exponent with it. It can be positive, negative, but we only have x to the first power. If it's y equals a number, it's constant. If we don't have any variables besides y, it's a constant function. Constant function, f of x equals c, or we could say y equals c, just y equals some number, is a constant function. Because it's not changing, it's not going up and down, it's remaining constant. Flat line. This is equation of a line. Squaring function, our quadratics, f of x equals x squared. Whenever we have a power of 2 connected to the variable, we call it a quadratic. Questions on this here. And they do have this characteristics. It's normally a U-shaped curve. The domain's all real numbers. The range of the function is a set of non-negative real numbers. The function's even, and the graph has an intercept at 0, 0. That's just for this one here. Because the domain for any squaring or any quadratic is going to be all real numbers. The range is going to be whatever the maximum or minimum value is and heading in one direction or the other. So this is our square. Then we have cubic, square root, and reciprocal functions. The first one we have is a cubic. F of x equals x cubed. Has the following characteristics. The domain's all real numbers. The range is all real numbers. The function's odd, and the y-intercept is 0, 0. Really, any cubic x to the third function is going to be all real numbers on the domain and range. The graph is increasing the whole way for this one here. It's not for everyone, but for that one, yes. We call it a square root function because it has a square root. Most of these are pretty straightforward. The domain is the set of all non-negative real numbers. Really, whatever is going to be x or make x be negative for this one here is going to not work. Or really, whatever is going to make whatever's inside the radical be negative doesn't work. We can't take the square root of a negative number. And the range is this set of all non-negative numbers for this here. We have this here. This is the reciprocal function, 1 over x. Because we have 1 over x, x is in the denominator, it's going to be the reciprocal function. And we restrict the domain to be all values of x. Well, x in this case can be any value except whatever is going to make the denominator be 0. In this case, it's just 0. And then we can find the domain the range from there. And we get this here. And I mean, for the most part, we know all these here. Now, the one that we're not as familiar with is what we call the step function. The most famous of the step function is the greatest integer function, which is denoted by this here. F of x equals the step function, or the greatest integer less than or equal to x. So, if we looked at the step function for -1, the greatest integer less than or equal to -1 is, well, -1. -1/2. The greatest integer less than or equal to -1/2 is still -1. And we can look at this here, but before we look at all these numbers, really I want to look at this graph, because whenever we pick a point between any of the values, we're always going down. Because as the last one said, -1/2 is right here. Well, we're going to drop down to this here. Because inside this here we would have indeed -1/2. So on the y we're at -1/2, so we drop down to -1. Now when we look at these others here, 1/10. Well, the greatest integer less than or equal to 1/10 is 0. 1.5 would be 1. 1.9 is still 1. And this is what we have here. Now, interestingly enough, the domain of the function is a set of all real numbers. The range is the set of all integers, because we don't have decimals on the range. Does this make sense? So what would the step function of 2.4 be? What do you think? Take a guess. So what is the smallest number, integer, less than 2.4? There's a number bigger than it that works. Let's try another one. Let's say 3.9. Yep, 3. Okay, how about this one? Still 3. Yep. How about -3.9? Almost. Because again, less than it. Because negatives are a little tricky, because -3 is actually bigger than -3.9. So we're still dropping down. And I would think of it dropping down in accordance to the y-axis. Because 3.99, if I drop down to the previous integer, that would be 3. But for -3.9, we go to 4. Does that make sense with these here? Piecewise. We'll talk about, the range instead of all integers, we have this here. So if we want to evaluate this here, f of -1, well, everywhere there's an x in the function, we'll plug in -1. Well, the step function for -1 is, well, and -1 plus 1 is? Yeah. So f of -1 for this here would be 0. Let's do f of 2. Well, the step function for 2 is, well, 2. Plus 1 is, so f of 2 would be 3. Now the last one, f of 3/2 would be the step function of 3/2 plus 1. So what is our step function for 3/2? It's not 3/2. Because 3/2 is the same as what? 1 point. It would be 1. And 1 plus 1 is? Yep. Because with that step function, everything from 1 to almost 2, 1.9 repeated, will be 2. Because it's stepping up as soon as we hit the next integer. Does that make sense? Questions on any of this here? So we get this here. This is the graph of this function. And it doesn't jump until we hit the next integer. So all the graphs that we have 8 that we looked at. We have constant, we have linear, we have absolute. We really didn't look at it, but absolute is pretty straightforward. It's a V on the graph where we have absolute values. We have radicals, or quadratics. We have our cubics. We have our quartics, or quadratics, cubics, reciprocals, and greatest integer, or our step functions. Questions on these here? You ready for the next thing? That's it.